what is meant by the bitwise? Bitwise means we have to do the operation on each bit, so that's why it's a bitwise. Okay, like if we have a register, okay, if we have a register and each register have the bits, let's suppose it is like 1 1 0 1 1. If I have this register, so if I'm doing any bitwise operation, so I have to take care of each bit. Okay, so let's suppose if I'm going to AND with this I'm going to AND this register with 1, so I am going to do the AND with 1 and 1. So each bit, this one with this one, this 0 with this one and this, so each bit we are going to take care. Okay, so here we will see the overall meaning, what is the instruction, what that instruction mean, and again, because why it says 0, because this is R type. So in always the R type format, our opcode is 0. So where this function value goes, this function value goes to our this function column, okay. Yeah. Whatever the opcode of our this function, like the AND or X or NOR, it's going toward our last function. This is the same as we see in our previous lecture. Okay, so if I see here, this the first one is AND S1 S2 S2. You know this, these two are your source register. Okay, source register, and this is your destination. This is your destination. Mean here you can see the meaning of the equation. Mean S2 and S3 are going to be AND. S2 and S3 are going to be AND. Okay, the one thing is the AND in MIPS, how we write, this is the we can say the representation, because the syntax, the AND we can write in MIPS is like this, with this letter. Okay,
so basically we take source 1 and source 2.
Yeah, it is like source 2 and source 1 and source 2, we are going to AND them and we are going to store their result in our destination S1.
And we will do AND or like OR dependent instruction.
Yeah,
we will put AND or NOR dependent instruction.
Yeah, depend on the instruction. Here you can see it is OR. Yeah. So OR sign is this straight line. Okay, so S3 and S2 is gonna be OR and they are going to store in S1. Same. Then next is XOR. XOR I told you with this cap. Okay, so S2 and S3 XOR and they are going to store in S1. Again S3 and S2 are going, okay, NOR. Again I told NOR is what? We have to find the OR and just invert it. So again here in bracket we are finding OR because this is OR sign, and we are going just invert it. We are going to invert this bit. This is your NOR. Okay, opcode is 0. Why? Because these are the R type format. Okay, here again the same thing. This is your first source register, second source register, and this is your destination register. So the first the source register is your S2, second source register is S3, and what is your destination? Destination register is S1. So your destination register in this all are the S1. So that's why all destination registers are S1. Got it? Shift amount. Are we doing any shift here? No, it's simple logical operation. So shift amount is 0. So what are these functions? So these are actually nothing. These are the AND, OR, XOR and NOR. The opcode function values. Okay, it's like 24, 25, 26, 27. Okay. So everything is clear here. Yeah. It is similar as we see in our previous slide. Okay. So here it come the example. Okay.